I notice I'm always way too serious whenever I'm recording a video. And this time, now, what if I told you that a machine learning model can be 95% accurate and still perform terrible? Yes, and can still be one of the most useless model out there. And that's exactly why machine learning engineers doesn't stop on accuracy. They tend to explore some other evaluation tools like confusion metrics. And in this video, we're going to be focusing on confusion metrics. Confusion metrics is one of the evaluation tool, in fact, one of the most important evaluation tool in machine learning and also in predictive analytics that is used in classification analysis. So it provides us with some other metrics like accuracy, precision, recall, F1 score. All of these four metrics are built up on confusion metrics. So that's why confusion metrics is one of the most vital. And then what does it do? Confusion metrics is used to compare the predicted values against the actual values. So it places it in a grid-like structure such that you know exactly where the model gets confused in making predictions. So it's defined by a block 2 by 2 matrix, which shows the true negative, true positive, and false positive and false negative. So these are the four elements that defines confusion metrics, and these are the four elements that you could use to extract accuracy, precision, and recall. And in most cases, new Bs in machine learning data scientists tends to focus more on accuracy. And in that case, whenever you focus more only on accuracy, you tend to build a system that is performing very terrible, because accuracy alone doesn't solve the problem. You tend to look at precision, recall, and F1 score. Now, let's take, for instance, you ask someone to go pick you a phone on the decks, and the person walks inside the room, carries the decks outside. So accuracy could say that you are 100% correct because you brought the phone. But then on the other hand, precision can tell you that you are making mistakes because there are a lot of misclassifications. There are things that are not phone that came outside with you. So recall and F1 score is also going to take consideration of some other elements that comes in that are not phone. So in that case, you tend to have a system that perform a lot more better than focusing only on accuracy. Now, let's take this analogy to, you get to understand how interesting it is to have a system that underperforms, but then has a very high accuracy. Now, for cases where you are doing something like cancer predictions, false negative becomes critical factor to, pay more attention to. And then for cases where you are doing stuff like email spam detection, false positive becomes a critical problem to focus more on. I'm giving you this as an assignment. You get to study more about confusion metrics and how it can be applied. But then let's take one simple analogy. For example, you're building a system that predicts whether if a patient is sick or not. In a hospital, it does diagnosis. So imagine that the system says that a sick person is actually sick. That means it predicted that a sick person is sick. That's a true positive. But then if the system now predicts that a sick person is healthy, that's a false positive. But then for cases where we have a healthy person and the system predict that the healthy person is sick, that's a false negative. And in that case, the person might be administered to, take medications which the system might not be ready to take in, and that could introduce a problem. So that's why it's very, very important that whenever we are doing a classification analysis, we tend to take confusion metrics in high consideration. When next you're working with a machine learning model, try and have your confusion metrics printed out. And also you can make a plot using a heat map, so you can have a colorful display of the numbers and as well as the intensity of the values. Thank you, and see you guys in my next video.